Hello, here's another video on simulation. We're going to do a couple simulations here. Now, consecutive heads. Here's our problem. To use the simulation steps to find the probability of getting a run of 4 consecutive heads when you flip a coin 10 times. Now, this is a very difficult question. It's not a easy theoretical problem to get is if you flip a coin 10 times, how many times you get 4 heads in a row. Um, it's not very clear. So uh, simulations make it a little bit easier to find this probability. The first thing we need to do is clearly assign numbers. So if we're going to do heads and tails, we can have a 1 represent heads and a 2 represent tails. Now, that's the first thing we have to do. Now, we have to make sure that we we run our simulation. So I take out the calculator and I do some random numbers again, and I'm gonna hit math to the right. I'm gonna look at number 5, and I'm gonna do a random integer from 1 to 2, and then I want 10 of those numbers, and then I hit enter. Now our goal is we're going to check. So here we're simulating. Not much to write on that, but here we're going to tally. So we want to say 4 consecutive, or we can just write no, not 4 consecutive. So if I look at these 4 consecutive heads, that's 4 heads in a row. No, I don't see 4 ones. Nope. Oh, I get it there. So that's my first one there, and I have a tally of 2 for no's. So far my simulated probability is 1/3, but we got to do more repetitions. Nope. Nope. Yes. Again, 1 yes for every 2 no's. Let's see if the pattern continues. Nope. Yes. So that's 1 on each. And every 5, I'm going to make a dash there. All right, I just paused the video and did a few more repetitions just so we have some idea on, because hopefully you had an idea on what I was doing. And so now, out of these, I made a tally mark. So now I made my tally mark, and now the probability of getting 4 consecutive, if I can write consecutive, is we got 5 of them out of 20 observations. So it's about 0.25. My simulated probability is 0.25. If I did more and more simulations, it would be closer to the theoretical one, but 20 is enough for this circumstance. All right, now let's look at this next problem. Oh, we already did that. We did it 20 times. Now it says where the trial is independent. Now we have to assume that the trials are independent in order to do this, because each time you you roll a die, we assume that it doesn't carry over from previous ideas. What were the probabilities? We got about 1/4. All right.